chapter 14 test is next class. Today I want to do the 14.3 in class examples. And then I have some spearmint practice problems because you guys stink at it. So I have some practice problems for you to get less stinky on. Okay?
I'm great severe.
In the meantime, though, Carrie and Danielle want to investigate if tapping on a can of soda would reduce the amount of soda expelled after the can has been shaken. For their experiment, they shook 40 cans of soda and randomly assigned each can to be tapped for either 0 seconds, 4 seconds, 8 seconds, or 12 seconds. Then, after opening the can and cleaning up the mess, the students measured the amount of soda left in each can in milliliters. Below are the data and a scatter plot. Data, scatter plot. Describe the direction, form, and strength of the scatter plot. Who can tell us this? Or Olivia.
I feel like a fairly strong, positive order.
So strong, linear, positive. Sounds okay to me. The next question reads, the equation of the regression line in the previous example is given as soda remaining equals 2.3 times tapping time plus 248.6. Identify the slope and y-intercept of the regression equation and interpret each number in the context of the experiment. Who can do this? Emerson. Anthony pointed to you and said you could do it.
The slope is like an average, so average as it moves up x amount.
So you need to stop using its. You got to put it in the context of the problem.
The line increases.
Nope.
What do you mean?
Quinn, you want to give it a shot? I see you waving at me. Oh, okay. What is 2.63 is slope, right? What is slope? What, rise over run, right? Or in terms of x and y, that's the slope-intercept equation. Slope is change in y over change in x, right? So 2.63 is going to be like 2.63 over 1, right? What is the y variable?
2.63.
No, what is the y variable in this problem?
The amount of time between taps.
Nope.
No, it's the amount of soda.
It's the milliliters of soda. What is the x?
That at the time.
And what's tapping time measured in? So the 2.63 means that for each additional second tapped, the can will have an additional 2.63 milliliters of soda remaining. Okay? For each 1 unit change in x, we're getting 2.63 units change in y. X and y have units, you just put the unit in there, but that's what slope means. Do I need to say that again? Okay, what does the y-intercept mean then? Or what is the y-intercept and what's it mean? Emerson, I'm going to come back to you. Redemption time. What's the y-intercept?
When y is
The number.
Oh, so you.
Just read the number.
238.6.
Yes, that is the y-intercept. And what does that mean in the context of the problem?
Isn't that what it equals 0?
So, gotta watch the personal pronouns.
When y equals 0? Or x? No, it's on the x intercept.
Okay? And we gotta use the variables in the problem. Brooks, you wanna try this?
The amount of soda that's in each in 0 seconds of tapping.
Okay, so it'd be the amount of soda remaining, that's what y is. So 248.6 milliliters of soda remain if the can is tapped for 0 seconds. 0 X's. Everybody okay with this? You guys, sounds like we need to practice doing this when you're studying. You'll be asked to do this on the test. Don't let me down and do better than what we did today, okay? Not hard, but you need to practice the book, like how to say it. Using the equation above, determine what the predicted amount of soda remaining would be for the indicated tapping times if applicable. For 5, what would we write? Or how would we find it?
2.63 times 5.
Plus,
248.6.
correct. We don't care what the number is. How about for 10? Same thing. How about for 30? Wrong.
No, oh, it's out of it's the extrapolation.
It is extrapolation, would not be applicable because 30 is outside the range of X values that we considered, right? The tapping times were 0, 4, 8, and 12. Tapping times between 0 and 12, this model will be applicable for. Tapping times outside of that range of values should not, that is extrapolation, we should not be using the model to apply to those. So the 30-second was a trick question. Are you gonna be ready for that trick on test time? You might see it again. Wink, wink. Wink, wink. All right. Example 4 says, from the experiment performed on tapping pop cans in the previous problem, find and interpret the residuals for the indicated cans. I tell you the residual is y minus y hat. So tapping for 4 seconds and a 260 milliliter can of soda. How do I calculate the residual? What is y? That is incorrect.
260.
260 is the amount of soda, the actual value. What is y hat gonna be? That is incorrect.
The wording on the question says that it's 260 milliliters per minute.
So that was the actual value. That's the y. Minus the predicted
Oh,
means that y hat is the predicted value. That will be our residual. Again, you're just plugging 4 into the regression equation, getting that number, 260 minus the number. Are you okay? Just got to know what the symbols mean. The arithmetic, the actual calculation, really easy, but you got to know what stuff means. How would you do tap for 8 seconds and had 255 milliliter soda remaining? Yep. And again, y hat is this guy right here, right? Guys feel okay? Again, whatever the number is, it is. Like, you have a calculator, you can type it in. I'm not worried about that part. I think most of us can type a number into our calculator and get a decimal come out and like do some subtraction, right? That's not the stumbling part. No, Anthony's problem is sig figs.
Yeah.
And rounding.
Problems.
Those are, Lucas and Anthony get all the conceptual parts and then they can't round or do sig figs.
I know it's pretty good.
Or even maybe it's reading the directions all the way.
Yeah, part of it was reading the directions.
Yeah,
I swear you changed it.
I know, it feels that way, doesn't it? I promise you, I didn't like sneak in when you weren't looking and change it on you. All right, example 5, we designed a study to investigate the relationship between the row that a student is sitting in and their grade on a particular test. We make the row number our independent variable with the row of value of 1 indicating the row closest to the front of the classroom. So row 1 would be like you guys, right here in the front row. Okay. Based on our data, we find the following statistics. Okay, so we have some means and standard deviations and a correlation coefficient. Use the formulas below to find the equation for the linear regression. Interpret the values for slope and y-intercept in the context of the problem. How would I find the slope?
R times standard deviation 1.
Right, just fill them in. Everybody's okay? How'd I find the B? Just, yes.
Times 1.03.
Okay. Who's got their calculator out and punching this through? Because I want actual number for this so we can do the interpret in the context of the problem. 135.
135 over
1.974.
that, and then, so m is equal to negative 1.132.
Great, that's 3 sig figs rounded correctly.
And then 8.2 minus times negative 367. Did you wrong? 81.2 minus. Wait. Oh! I did times. That's where I'm wrong. Yeah, 85.72.
Or really the 3 sig figs.
Yeah.
Okay, all right. Who can interpret these values in the context of the problem? Anthony,
Yeah.
let's show off. Let's see it. Put on your white hat.
Yes. Oh, my Y hat.
Get it? Instead of your like mat hat, you call it the Y hat. It was your Halloween costume.
Okay, so the regression line. So, in the context of the problem, you said?
Yeah.
Okay, that would be helpful. So, 85.7. Is that what you want me to? 85.7 is the so it's the yeah. Yeah. It's the score.
That's
Yeah. So it's the expected test score
okay. When
there it's zero, the other one's 0.
what's the other one mean?
And,
When a student
when the
is student in the first
It's in the
Not the first row,
Front row.
the 0th row.
Zero row.
Yeah, it's 0 because then it would.
First row was 1. Row 0, if 1 is the row at the front of the class, what's row 0?
Your desk, I guess.
In my desk?
Standing in front of
I don't know,
someone.
Okay. What's the M mean?
So the M is the slope. No, it's the.
Yeah, that's a slope.
It's the. Oh. It's the variable of the score. The average of the score.
No.
No, it's the.
It's a figure falling.
It's negative 1.12 for each row for the back. Oh, so for each row back. It specs there. Test.
Why are you stuttering?
Speak. Decrease. 1.2. What negative? Oh, is it? Yeah.
So each change in X results in M change in Y, right? You just have to,
Okay.
instead of saying X and Y, you have to say the unit and variable, the quantity from the story problem. So you have to like read the story problem part. Everything you need is in the story. So are you okay with how I wrote that? Okay. All right, last question. 10 students in a mathematics course measured their height in inches and weight in pounds to determine if any correlation exists between the two measurements. They make the value of the height the independent variable. The table below gives the recorded values. Use your calculator to find the least squares regression line for the data above. What is that asking you to do? How am I using my calculator to do this?
You plug it in.
What operation on my calculator do I need? What's it called?
Lin-reg.
Lin-reg.
And then you score.
Someone say my word.
Okay? So I'll enter your data into list L1 and L2,
First one.
and then you're just doing lin-reg L1, L2.
We're gonna get our.
Everybody's okay?
I have that.
Part B,
Why is it tarnished?
check that the regression, or check the equation for the regression using the formulas. How would I do that?
Do you have to plug it into all those formulas?
Well, this is what your answer looks like over here. So you're just checking for M and B. So to do the checking, all I'm gonna do is do the two variable stats. That's gonna give me everything I need, and then I can just plug everything into the formulas and check to make sure my my M and B in part A match what I'm getting in part B.
Which, line did we do?
I just do the first one. It doesn't matter. If you look at the equation, it's just like the only thing that's different is the name of the letters or whatever.
Oh, yeah. I just want to make sure.
Yeah, so it doesn't matter. I don't know why there's two in there. I've never really understood why they have two versions of it. And then it says use the calculator to graph the data as a scatter plot with the linear regression as well. So the only thing I would do different to get the linear regression on here is when I do my lin-reg L1, L2, I'm going to store the regression equation to into y1. So I can graph, it'll put the equation in there for me, I don't have to copy it in by hand because probably A and B are like 100 decimal places long and like, forget that mess.
What do we press to get Y1?
Bars, over to y bars, and then you select y1. When you're a math teacher, you have all this memorized. Because you've done it 1,000 times. And also the names of the buttons kind of make sense, that like the variables live in the bars button. Any questions on what we've done here today? I know I coasted through some of this stuff, but this is relatively easy, other than being able to like describe what's going on in words, which, God help us, we need to practice. So like, make sure you practice that stuff. Yep. I'm gonna also right now pass out for you guys some spearmint practice problems. So I have 3 data sets
Thank you.
that I want you guys to work on. I haven't written out a key for this yet, because quite frankly, I wrote them at like 7 o'clock this morning after I got home from grading your quizzes last night. Been like, Lord help us, we need some work on this.
Thank you.
You're welcome. So I will be sitting down and doing this alongside of you. So they'll go from relatively simple. Hold on.
Are we doing spare?
Let me get one from Daniel too. You haven't hold on to it, I'm sure. I know, make him give you something for it though.
Yeah.
Like, put a ransom.
Oh, I was like, why do I have so much?
One for Lexi, one for Kevin, one for Daniel.
You were close.
Yeah, make him really, that's appropriate. There you go.
I was that, Mr. Cole.
What's up?
God bless
Pick
you.
it up, Kevin.
Yes.
You were so slow. It's Olivia. Pick it up.
All right.